Alright guys, so we're going to do something new today. It's going to be really familiar though, because what we're going to do is we're going to use skills of linear equations, like y equals mx plus b, to graph linear inequalities. Now here's a problem from the algebra regents. It's from a past one, obviously. And for the next two notes, I'm going to be prepping you guys how to answer something like this. So how do these equations, or how do these things look different than most of the things we graph? Well, obviously, y isn't by itself first off, and it's got this sign right here. So today's notes is all about how to graph something that has one of those signs. All right? So I think on the next page is where we start. Oh, I said, how does this problem differ from the problems that we've answered already? It has an inequality versus an equal sign versus an equation. So let's work on some of the basics, like we're starting on next page. And I actually have some vocab for us first. The first vocab word is linear inequality. It's similar to a linear equation, but the equal sign is replaced, and a solution to a linear inequality is any coordinate point that makes the inequality true. And a big difference here is that there's going to be lots of them. There's going to be lots of solutions to an inequality, unlike an equation where there's just the line that's the solution. All right? So there's some steps to graphing one of these guys. They're going to look a little bit different than the typical ones. They're going to look like these guys down here. So the three steps that I want us to take is, first off, I want us to graph the slope and y-intercept. And this is going to be like how it always has been. All right? The second one is we're going to look at the sign to see the boundary line. And I'll talk more about that here in a second. Actually, I'll talk more about that right down here. And then step 3, again, we're going to look at the sign to shade. And I'll explain that here at the bottom. So what I mean by the step 2 here, the whole boundary line, there's going to be two different types of lines. So whenever our symbol is like this or like this, our boundary line, instead of being a straight line, is going to be a dotted line. It's really, really similar to when I asked you guys to graph x's like greater than 3, and you'd make your little inequality, and you wouldn't fill in the circle. It's like the same exact thing, because here, when the symbol looks like this or like that, it's going to be a straight line, just a normal solid line. All right? So that's pretty easy. So let's do those two steps down here on example 1, and then I'll show you the last step, the whole shading part. It gets to be a little bit confusing at first. So first off, I'm going to graph my y-intercept of 4 and my slope of 1, so it looks like this. All right? Now here's how it becomes a little bit different than what we're used to. We have to look at the sign and say, okay, that has no line underneath it, so instead of being a solid line like we're used to, it's going to be a dotted line. All right, so there's that. The last step, because it's an inequality, either one whole side of this graph, like this side, or the other side are all answers. And I'll explain that more here in a second. So what we're going to do is we're going to look at this sign, and we're going to see that it's this way, which means less than. And because that means less than, what we need to do is we need to shade the lower part of this graph. So we need to shade every single coordinate down here. And what that means is every single one of those coordinates would actually work if I plugged it into this inequality. Like, let's just pick one or two that's super easy. Like, does everyone see how 0, 0 is a point that's shaded in? So if I plugged in 0 right here and 0 right here, you see how it would say 0 is less than, well, 0 plus 4 is just 4. So that works, which means I would shade in there. But that's not the only one. Every single point on this side would work. Like, let's do I don't know, 5, 1. If I checked 5, 1 in up here the same way that I checked 0, 0, so 1 would go right there and 5 would go right there, and then it would say 1 is less than 5 plus 4 is 9. So that one's good too. Hopefully you get that every other point on here works. I'm not going to try any other ones. If you'd like to try some of these other ones, feel free to pause it and do that yourself, but I think you got it. All right, so let's do this a couple more times, and then we'll get pretty familiar with it, and then I'll have you guys do some on your own. All right, so I think I went one too many pages. All right, so example 2, let's take a look at this guy. First off, just like it used to be, we're going to graph our y-intercept and our slope. 1, 2, 3, 4. Actually, it's not going to work, so I'm going to have to go backwards in time. I'm going to have to go down. 1, 2, 3, 4, 5, and over 1. And I'm going to graph this. And it is a solid line because there's a little line underneath. Now, this. That sign means greater than. You know, if you had an X and a 5 here, it would say X is greater than 5 because the alligator's eating the X. So because it's greater than, we're going to shade on top of this line. And on top of is everywhere over here. All right? Which means everywhere on this side are not our solutions, but everything over here is. So like if I checked, I'm just going to check another one for you. Let's do, well, -3, 2. Let's check -3, 2, just a random one. So I'm going to plug in -3 and 2. So now it's going to say 2 is greater than or equal to. -3 times 5 is -15 plus 4, which obviously is going to be 2 is greater than some negative number, right? -15 plus 4, I think, is -11. Obviously, that doesn't work. But if I checked, like, I don't know, 1, 1. 1, 1 is not a solution. So if I took our inequality again, that y is greater than or equal to 5x plus 4, and I plugged in 1, 1, it would say 1 is greater than or equal to 5 times 1 is 5 plus 4, which is 9. Does everyone see that one does not work out nice? So that's the side that's not shaded on. I knew to shade this side right from the very beginning. All right? Let's take a look and see what's down here. Here's one that's a little bit more difficult, but one that I've seen a lot. X is greater than 3. I've had us practice this a lot on IXLs. This one is weird. There's no y equals. So this is the one, some of you guys should know, that looks like this, right? The line that's going up and down. The only thing is if I draw this, it's wrong. Can you tell me why it's wrong? Obviously, this sign means that it needs to be dotted and not solid. So what you could do is you could just go like this and erase a couple. That's good enough. And now I just need to look and see what side I should shade on. I need to see, well, because x is greater than 3, it's all the things that are bigger. Which all the things that are bigger is this side over here. All right? So there's that. I think I have us trying 2. Maybe even more than 2? No, just 2. All right, so would you please try these 2, pause your video, and then unpause it when you think you're done so you can check. All right, hopefully that was enough time. Let's take a look, and let's do this one pretty quick. I'm going to go up on 7. That's my y-intercept, and I'm going to go up 5. Unfortunately, I can't, so I'm going to go down 5. 1, 2, 3, 4, 5, and backwards in time. 1, 2, 3, 4, 5, and backwards. Is my line solid or dotted? Hopefully you said solid. And now it's the whole shading part. This is greater than or equal to, so it's going to be on top of. So it's going to be over here. Okay? That's not that bad. Let's take a look at this guy down here. So I'm going to go down on 4. I'm going to go down 1 and over 1. And I'm going to look at my sign. That tells me 2 things. First off, it tells me that it should be dotted. And it also tells me that my line needs to be below because this is less than. Like if it said x is less than 4. Because it's less, it's lower. And the side that's lower would be here. That's below it. So it's all of these coordinates that would work. All right? All right, so the next part of these notes, I say, are going to step it up a little bit. I'm going to have you practice the equations that are not solved for y. These are probably the ones that you're going to see. This is how it looked on that first question. All right, so it says graph the solutions to this guy. We've done this in the past. We've gotten y all by itself, so let's do that. We're going to draw our line down, and I'm going to say, how do I get rid of this 2x? So I'm going to subtract 2x from both sides. And I'm going to get y, same sign, negative 2x plus 4. Step 2 says graph the boundary line. Well, we also need to graph this, so I'm going to start off on 4, go down by 2 and over 1. And it even says use a solid line. All right, so there's that. Last part is I need to figure out which side to shade. Because it is this sign, and that sign means less, it's going to be lower than. And the side that is lower is this side over here. So all of these answers are my solutions. Okay? So would you guys pause the video? Please try these two, and then unpause it when you think you got it so you can assess. All right, hopefully that was enough time. I'm going to add an x on both sides and get y, same sign, x plus 3. So now when I try to graph this, I'm going to go up on 3. I'm going to go up 1 and over 1 a couple times. I'm going to look at my sign and say it should be dotted. And because this is less, it needs to be lower than, and the side that's lower than is over here. All right? Last one. I'm going to get rid of the x by minusing an x on both sides and end up getting y plus 2, same sign, negative x plus 0. I'm going to minus 2 to get y, same sign, is greater than or equal to negative x minus 2. All right, so now let's get my minus 2. And I'm going to go down 1 and over 1. Is it going to be solid or dotted? Solid. So let's make this a solid line. And let's figure out what side to shade on. Now this means greater than or equal to. So that means that it's going to be above. It's greater than is big. So if it's above, that's all of these coordinates up here. Okay? That's it. The last part of these notes, we're almost done. Last thing I want to show you is if they give you a graph, they're going to give you this and they're going to say, okay, tell me what the inequality for this is. You guys see how it's shaded a little bit nicer than what we can do on here. So I know that it's one of two of them. I know that my y-intercept is negative 2 and my slope looks like it's 1. So I know that it's either y is greater than or equal to 1x minus 2, or y is less than or equal to 1x minus 2. Right? And I know that it's this or this one because it's solid. Then all I need to do is look at my shading and see, well, it's up above. If it's up above, that means that it's greater. So that it's going to be this one right here, because this one means greater. All right? So would you guys please try on number 6 and tell me what the inequality is for that one. Pause the video and then unpause it after you've had a chance to do it. All right, hopefully that was enough time. My y-intercept is 4. My slope looks like it's 2 over 1. It's a dotted line, and it's lower. So if it's lower, there's less, and it's dotted, so there's no little line underneath it. So I got y is less than 2 over 1 x plus 4. And that's it. Some final thoughts for today. If the line is dotted, then there is no equal to. Remember, more to the line, more to the sign. That's what we talked about when we did these guys back in the day. And said, okay, well that one is when it's filled in. All right? To see which side, we're honestly not going to do that one. You always need to solve for y before you can graph anything. And finding the equation, narrow it down to 2 choices, and then use the inequality symbol. to narrow it down to 1. And that's it, guys. Thanks for watching.